We'll start with Jayraj Nair. He's the CTO of High-Tech and APAC at Ansys. We also have Jeff Wittich, Chief Product Officer from Ampere, and we have Sungyeon Park, CEO of Rebellions. And I'm just going to start with a quick introduction for each panelist to introduce themselves and their companies. Why don't we start with you, Jayraj?
Excellent. Good afternoon. Thank you for being here at this time of the afternoon. We have a lot of interesting topics to talk about. I'm Jayraj. I'm based in Seattle currently, but on the way to Japan. I'm the field CTO for High-Tech as well as APAC. And Ansys, most of you must have heard of Ansys. It's the #1 simulation engineering company in the world. Looking forward to sharing some insights today.
Jeff?
All right, Jeff Wittich. I'm the Chief Product Officer at Ampere. Ampere has been building processors for data centers, for cloud, for the last 7 years. And our aim is to build high-performance processors that are also extraordinarily efficient. And as workloads have shifted, and with the rise of AI, those processors that we've built for data centers are also making their way into telco and into the network edge as well.
And Park?
Yes, Sungyeon Park. I'm co-founder and CEO of Rebellions, which is Korean AI chip company. We're currently using Ansys tools, fantastic. We're also collaborating Ampere for national AIDC project, something like Korean Stargate. So we Rebellions, Korea's only deep tech unicorn. We recently got merged SK Sapion last December. So our focus is on inference, as mentioned, AMD and Intel talked about, especially LLM inference. So our technology, which is distinguished from other AI chip startups, is high bandwidth memory and chiplet-based technology, scalable network on chip, sub-memory systems, customized UCIe protocol, something like that.
Well, let's go then, guys. I could say that 2024 was an interesting decade in tech, just in terms of the pace of innovation. 2025 is promising to be a major year for advancement of enterprise adoption of generative AI and all sorts. We're just going to start with exploring where that technology trend is going. And Park, would you like to kick us off?
Sure. As Alice mentions, let me talk about the fundamental AI workload. We have tools, training and inference. From our perspective, a little bit complicated, but from business perspective, training is kind of research and development. This is R&D. On the other hand, inference is where the actual business begins. That's the key differentiator from enterprise perspective. So as AI services get more popular and increasingly monetized, like #2 DeepSeek, another DeepSeek again and again, then inference traffic dramatically goes from the edge to the cloud. Eventually, it's kind of the hybrid from the rack to the cloud. I think it's really, again, it's the year of inference. It's the year of AI service, not AI R&D anymore. Inference, that's exactly 2025.
Now, Jeff, I've been following Ampere for a long time, and you guys have had great inroads into the data center. But you're here at MWC talking about platforms for comms. Tell me about that and how you see that shaping your broader strategy.
Yeah. So like I said, we initially set out to build processors for cloud and for data centers. And what we were trying to tackle was the emerging power problem. Obviously, our processors deliver a lot of performance, but even more importantly, the focus is on delivering that performance at very, very low power. And we've all seen the complications that have occurred over the last couple of years as AI has taken hold within data centers. And as we move from training to inference, that problem just scales out everywhere. And so we've seen that scale out across data centers as they seek to keep up with the demand for running these AI models at scale in lots of locations. Well, those AI models aren't only running in clouds or in enterprise data centers, those AI models are increasingly running everywhere. They're running out at the edge, they're running in endpoint devices, and so that was sort of the natural point for us to expand out into the comm space, out into the telco space, because those same challenges that we were seeking to solve within big hyperscale cloud data centers are increasingly now problems in telcos. And those same power problems remain. We've heard this a couple times here in the session, that the environment that this hardware is being deployed in is really constrained. It's constrained from a power perspective, it's constrained from a space perspective, it's constrained from a thermal perspective. And so those same things that we did within our hardware to solve for those problems within data centers now equally applies out into the telco space, where you have a demand for a lot of performance, and you need to deliver that in a really, really efficient manner.
Now, Jayraj, Ansys makes ridiculously powerful tools for design simulation for anything from a chip to solutions from across industries. You have a really unique perspective in terms of the environments, probably the most unique perspective on stage in terms of the environments that these foundational platforms are needing to be deployed in. What does that tell you about the broad proliferation of technology that we're talking about today?
Lots of change in the last few years. If you look at simulation engineering, actually brings kind of superpower to the Ampere and all the silicon developers. It actually brings certainty superpower, which is in the design life cycle of any silicon, you have to go through understanding whether a design has got signal integrity issues, a design has got power integrity issues. What has happened over the last few years is the billions of transistors, the scale factor, density, and now the chiplet architectures, right? You had Salil talk earlier about MI325, the multi-layered chips. You had Intel talk about the SoC, Xeon SoC. All of these are complex architectures. So today, if somebody is trying to build a very bespoke silicon, they bring chiplets, they put it all together, they have interconnects. That all also affects something called IR drops, voltage drops, so that releases more thermal and heat. So now you have to model not just signal integrity and power integrity, you have to model thermal integrity. And the chips get so hot, you have a mechanical stress warpage. And when you have that, you add new interposers. So complexity has gone through the roof. So to do simulation of all of those multi-physics at the multi-scale level, from nanometer to a chip which is at a millimeter level, to a board that is at a centimeter level, to package which is at a centimeter level, to a systems level, is highly complex. So multi-physics simulation engineering is at the core of making a silicon successful. And not just the silicon. I think, frankly, silicon to systems was a conversation we had. I think if you take the silicon, put it in a board, put it in a server, put it in a rack, and put it in a data center, you have to start worrying about data center cooling and power performance efficiencies at the data center level all the way to the chip level. So it's a very complex world.
Now, you guys have just given me, as a chip head, incredible faith in engineering innovation. And I think that we've seen that play out in the silicon arena for the last couple of years. Just incredible advancements in pushing up against the laws of physics.